Hi everyone, Mrs. Below here. In this video, I'm going to be going over the last two slides of the mole notes. So previously, with the other two types of picket fence problems associated with the mole, if you saw atoms or molecules, you would use Avogadro's number. Atoms or molecules, depending on what the problem is asking about. And if you saw grams in the problem, then you'd have to find molar mass. And remember, molar mass is whatever amount of grams, depending on the substance, that you calculate from the periodic table is equal to 1 mole. So this just is determined by the substance and the decimal number on the periodic table, which is also the atomic weight, or the average of all the isotopes for that element. And it's also the molar mass for that element. So in this problem here, it says find the number of molecules in 60 grams of N2O. So that's dinitrogen monoxide. So you of course will start your picket fence with whatever's given to you in the problem. In this case, 60 grams. Now in this problem, I'm seeing molecules and I'm seeing grams. So that means I'm going to have to use both of these now instead of just using one or the other. So to begin, I'm going to leave this here, Avogadro's number. This is on the back of your periodic table. I'm going to have to calculate the molar mass of N2O. Because ultimately, in my picket fence, I'm going to have to put grams here, and therefore I need to calculate the molar mass of N2O. So nitrogen is 14.007. We're going to multiply that by 2 because there's 2 nitrogens. Plus oxygen is 15.9999. 15.999. All right, so 14.007 times 2 plus 15.999, 40.013, 44.013. Again, this is grams per mole, but you can also say, which means the same exact thing, this many grams equals 1 mole, which is something that you can plug in to a picket fence. So in my picket fence in the bottom here, I know this has to be grams. I'm going to plug in 44.013 grams. That's coming from here. And then above that, I have to put what it is equal to, which is 1 mole. Grams cancels, and right now my answer is in moles. However, I need my answer to be in molecules. So that means I have to continue my picket fence. I'm just highlighting where I'm getting those numbers from that I'm plugging into my picket fence. All right, in our next step of the picket fence, I know moles has to go here. Now you're probably thinking, how many moles? We already used this. We already used molar mass. And we want to get our answer into molecules. Well, now I'm going to use this 1 mole. Okay? And that is equal to 6.022 times 10 to the 23rd. We're going to use molecules because that's what this problem is asking about. And that's where that is coming from. We use molecules. Moles cancel. I'm just left with molecules, which is what I wanted my answer in. So now I have to multiply everything in the top. So 60 times Avogadro's number, times 1, 6.022, E23, enter. And we're going to divide it by what's in the bottom, 44.013 times 1. So 8.2, I'll go 4, excuse me, significant figures, 8.209, excuse me, 8.209, E23 is fine. You could write this as times 10 to the 23rd molecules. Okay, so basically we're just combining the two types of picket fences we were doing before into one problem, just making it a longer picket fence. Now I'm going to go ahead and do the last problem here. How many grams are in 3.022 times 10 to the 24th atoms of iron? So of course I'm going to start my picket fence with what the question is providing me, atoms, and we need to get that into grams. Again, I'm seeing grams in the problem, so I need molar mass, and I'm also seeing atoms in the problem, so I'm going to have to use Avogadro's number. And I'm just going to write atoms, and I'm also going to need the molar mass of iron because I can see grams in the problem. And it's just iron, it's not a compound, so it's just Fe, which is 55.845. So 55.845, and again this is grams per mole, which is the same thing as saying this many grams equals 1 mole. This is just a format we can plug into our picket fence. I know the units atoms have to go here. And I'm like, okay, well, how many atoms? Well, I have Avogadro's number, which is in atoms, and that is equal to 1 mole. Atoms cancel. Now I'm going to use, let me just highlight where I'm getting this from. 1 mole. I know moles have to go here. And I'm looking now at my molar mass. 1 mole is equal to the molar mass of iron, which is 55.845 grams. Moles cancel. I'm just left with grams, which is what I wanted my answer in. So I'm going to multiply everything in the top. 3.022 E24 times 1 times 55.845, and then enter, and then we're going to divide that by what's in the bottom, which is Avogadro's number, 6.022 E23 times 1. So 280, we'll go 4 sig figs, 0.2, so 280.2 grams. And that's it.